My name is Fritz Passmann. I'm a lecturer in optics, co-developer of the 3D refraction system Pascal, and always strive to be a mediator between theory and practice. As an optician, I am very interested in the subject of prismatic corrections to help improve the customer experience. Thank you for taking this time to join me wherever you are in the world. A communication challenge between industry and opticians. Implementation of prismatic corrections in comfortable eyewear.
There are three players in this game. We call this the Supreme Trilogy: the customer, the optician, and you. We all understand our role differently. Today, I will demonstrate how to bring the three elements together in order to elevate the customer experience. The typical questions the optician has after receiving lenses. I am sure you have heard these questions before. In which direction do I correct the PD when edging the lens? In most cases, the optician doesn't even know the PD from the lens manufacturer. Even when the prescription comes from the ophthalmologist, there is still no PD. How do I measure the prism value? The optician doesn't know the difference between the measured value and the implementation, neither the prism reference point nor the value for the prism reduction. The optician would like to make the prism distribution, but can't pass any necessary information to the lens manufacturer to optimize the customer usage. How do we understand the confusion of alignment reference markings? Should the lens manufacturer autocorrect be respected, and if so, when? And finally, not all opticians are able to determine which frame is best for lens diameter. First, some basics. Let's start with white light. It is the sum of all the colors. We have known this since the days of Isaac Newton in around 1700. Higher frequency blue light gets refracted more than lower frequency red light. Therefore, a prism will blend blue light towards the base more than red light. Prism power is measured in prism diopters, which is defined as the amount of light deflection in centimeters at a distance of 100 centimeters. One prism diopter is equal to 1 centimeter of deflection over a distance of 1 meter. The rule of thumb, 1 degree corresponds to 2 centimeters per meter of deflection. The optician always refers to the Prentice formula, which measures the decentration distance of a lens. Actually, we should think a step further. Because the eye rotates behind the lens and looks through different positions in the lens, the optician should use the Weinhold formula, which takes this into account. So, the extended Prentice formula, the Weinhold formula, the rear vertex distance plus the distance to the center of the eye, B, becomes more important. However, the diameter of the eye is not defined. The industry assumes a radius of 13.5 millimeters, but this cannot be measured. It is virtual. Z is important for lens centration. The optician cannot know the exact effect of a prismatic lens in front of the eye, and the calculation is therefore in the hands of the lens manufacturer. Trial frame versus the eyewear. In this example, once again, the influence of the rear vertex distance on the prismatic effect. I would like to point out the importance of fitting frames and measuring. This is the job of the optician. In this example, a 5 millimeter difference results in an additional shift of 0.5 millimeters in the opposite direction. The optician thinks in terms of convergence and squint angles. This is limited to the surface of the lens and a pair of eyes. The lens manufacturer thinks in terms of the angles of an optical prism. How many degrees do I have to tilt the lens to achieve this prismatic effect? Blocking. As far as I know, freeform technology does not solve this problem. A combination of both technologies seems possible. In conversations with technicians from the lens industry, I didn't get a definitive answer. I would be delighted to learn from you. The maximum prism power is determined by the edge thickness of the blank. The edge results in an aesthetically beautiful glass. So back to the PD. If the optician measures the rear vertex distance without prismatic effect, for example, using a videocentration system, the fitting height for infinity has to be corrected during the lens manufacture for every lens type. This is a major communication problem between the optician and the lens industry. Is the PD now converted? Who does the conversion? And what value should I use for the decentration? Later, I will talk about relocation of the alignment reference points. If the optician does not provide any additional PD information, the lens manufacturer must rely on industry standards. But does the optician know this? For example, some manufacturers, Zeiss, they assume a conversion has been calculated, whereby others, example Rodenstock, uses the raw fitting height. The prismatic prescription. Very important. Without specifying the PD and the vertex distance, a prismatic prescription cannot be performed. In this slide, we see the trial frame and the correction lens in a refractive prism. If the PD is not corrected according to the rule of thumb for prismatic prescriptions, an additional prismatic effect of the lens arises. This can be significant, and depending on the base position and the type of the lens, the prism can be strengthened or weakened. In the example above, a plus lens and a base below is equal to stronger, and a minus lens with base below is equal to weaker. The orientation of the lens in the final eyewear and the printed value on the correction prism is important. In effect, will the labeling on the trial prism be the same as the value in the final eyewear? Is there a difference between the base deflection position? Is the eyewear lens in the same position as the trial prism was in the trial frame? In the example above, during the refraction, the edge leans forward, while in the final eyewear, after glazing, it leans backwards. The final lens in the eyewear compounds both the prism and the trial lens and the trial prism. This is calculated by the lens manufacturer, but what is the calculation based upon? The classical dilemma, the difference between the prism value in the final eyewear and the lens meter value. The optician does not have access to the same measuring technology as the lens manufacturer. So my suggestion is that the lens manufacturer prints the refraction prescription and the resulting prescription on the delivery lens envelope. In our example above, in the prescription, we have a sphere of -7 and a prism of 11. But reading on the lens meter, we see a sphere of 6.8 cylinders, a sphere of 6.8, a cylinder has been introduced of +0.55, an axis of 105 degrees, and now the prism value is 10.8. Criteria for prism prescription. It is not your position to question regulations, but in the interests of due diligence, the following tips could help the optician and lens manufacturer cooperation. Prism-based temporal is counterproductive for near vision. Prism-based nasal favors convergence. In cases of enhanced exophoria and infinity, beware that prism nasal base overcorrects convergence. Don't be shy to prescribe vertical prisms. The lens order form. I do not recommend that the optician uses decentration to affect the prismatic value. The tolerances are tight in cases of high or low strengths. Also, the optician must think in terms of both directions, the sphere and the sill. For a sphere of +3 and a sill of -3 at an axis of 90 degrees, a horizontal prismatic effect cannot be achieved. If the prismatic effect is left to the lens manufacturer, the manufacturing tolerance is taken into account from the fitting cross and not from the optical center of the lens. Varifocals. Anyway, In the case of varifocals, it is not possible for the optician to create a prismatic effect using decentration. This is not known to every optician, and I would like clear guidelines from the lens industry how the optician should adjust the PD in tenths of a millimeter to preserve the prismatic effect. Some manufacturers already provide this information. Chromatic dispersion. My recommendation regarding refractive index is that the first choice should be take a 1.5 index, and where possible, use mineral glass as the best option. Exceptions exist where the customer's visual acuity and sensitivity are low. However, the chromatic dispersion reduces the vision. Here you see the retention of a squint angle, 8 degrees, using a single prism. It is possible to distribute prisms over both eyes. Instead of using Prism 4 for one eye, you can use Prism 2 for each eye. However, where the prism value is low, I recommend not to distribute the prism over both eyes. Instead, use the full prism on the non-dominant eye. Ask the optician which frame will be used. This will help you to optimize the look and weight and the fit. In the case of high prism values, the optician should inform the lens manufacturer where the bevel is positioned. In our example, we see 4 different positions: parallel to the front face, which is standard, 1/3 back, in the middle, 2/3 back, or parallel to the back face. Now back to the order form. All these points should be summarized on the order form. It is important that the optician has the opportunity to tell you how they worked. In addition to the refraction values, the order form should include comprehensive information such as the slot positions in the trial frame. Was the PD corrected? If so, by how much? Or was it only partially corrected? The rear vertex distance in the trial frame and in the eyewear. Other individual dimensions, in particular the shape of the lenses to optimize the lens thickness, and of course, the desired bevel position.
All these factors are summarized here. The case history, the participation and motivation of the client, the refraction, the testing of the dominant eye, the lens technology, the eyewear choice, the centration and glazing, and at last, customer coaching. Success depends on each single point. The chain is only as strong as its weak link. It is my intention to create a procedure to optimize the communication between the ordering optician and the executing technician. Thank you for listening and spending time with me. I appreciate your participation. Please feel free to contact me. Big thanks to Eric Fischer for translation and voice over.
Hello, everybody. Hello, Fritz. Hello, Peter. Hello, Eric.
Hello.
We just heard a lecture by Fritz Passmann about the implementation of prismatic correction in comfortable eyewear and the emerging challenges. And now we would like to ask you, Fritz, some further questions about your interesting topic. And therefore, I like to hand over to our expert and chairman, Peter Baumbach.
Yeah, thank you, Hannah. I also would like to say hello to Fritz, to Eric, and to you, Hannah. Fritz, that was a very interesting and important video presentation about the pitfalls of prismatic correction. And as a lens designer, I know very well all the problems you mentioned in your presentation. And I also know that at least some of these are difficult to understand for people who are not involved on a daily basis in prism correction. So before we go into deeper detail, let's start with a general question. I would like to know how precise or how accurate a prism correction should be according to your experience. Do you think that, let's say, a 5 or a 10% difference between the refraction situation and the final wearing situation, is that already too much for a successful real-world prism correction?
Yeah. Hello, everybody. First of all, I would like to apologize my bad English. So the answer I will give in German, and thank you very much to Eric Fischer to translate my answers in English. Ja, also ich denke, man kann es schlecht in einer Zahl angeben. Und es wird sicherlich von Glashersteller zu Glashersteller verschieden sein. Bei einigen mag es nur 5% sein, bei anderen sicherlich mehr. Mir ist aber wichtig, ein Bewusstsein zu schaffen für exaktes Arbeiten, um Fehler auszuschließen.
Okay, let me just explain or translate what Fritz said. First of all, I'm not a dolmetscher, I don't do online translations. But what I try to do is to translate the spirit and the meaning and the feeling of the person who's speaking, in this case, the passion that Fritz is showing in this subject. So he's saying about the question of 5% or 10%. He's saying it's hard to give a number. I mean, it's certainly different for each glass manufacturer. For some, it's only 5%. For others, it's certainly more. I want to create awareness for precise work in order to rule out errors. That's his answer.
Thank you for your answer. But I'm not totally satisfied with your answer, because let me go, or let me ask the question in a different way about the accuracy. On slide 8, as far as I remember, you say that a 5mm shift of the back vertex distance of the lens results in an additional lateral decentration of 0.05mm in the base opposite direction. I guess this value also depends on the prism value, but do you actually believe that such a small correction can be taken into account in mounting ordinary lenses? To my understanding, conventional edges are not able to be much more accurate than 0.5mm or so. And even worse, how are you going to check the final glasses so accurately?
Da hast du sicherlich recht. Und es ist auch nur ein Beispiel, diese kleine Zahl. Mir geht es darum, dass sich Fehler ja addieren können. Und zwar in eine Richtung addieren. Und allein die Kommunikation über diese Werte oder über diese Fehler führen am Ende zu einer besseren Versorgung des Kunden.
Okay, so the gist of what Fritz has said is that, I mean, here too, the errors can add up in one direction. And communicating these values will definitely lead to a better care for the customer. Is that it, Fritz? That's really what you wanted to say?
Okay. Okay. I was wondering why you recommend a refractive index of 1.5 and mineral glass for your prismatic corrections. These are not very popular claims for opticians, at least in Germany. They want to sell more expensive lenses, and of course with higher prisms the edge and center thicknesses and the weight will rise, and so it can be a problem for the wearer. Can you shed some light on this?
Ja, das ist auch ein sehr guter Punkt, der mir auch wichtig ist in der Kommunikation. Aus eigener Erfahrung kann ich sagen, dass Silikatgläser deutlich besser in der Transparenz sind, also letztendlich in der Brillanz des Sehens. Und das muss mit dem Kunden diskutiert werden, von Augenoptikerseite aus. Der Kunde sollte aufgeklärt werden über alle Möglichkeiten, Vor- und Nachteile. Nur dann hat der Kunde ja eine echte Wahl zwischen Sehen und Aussehen oder Gewicht und Glasdicke, was ihm am wichtigsten ist.
Okay, so Fritz is explaining, excuse me, Fritz is explaining from his own experience. He says, I can say that silicate glass has a better transparency, i.e. has better brilliance in vision. This should be discussed with the customer. It should be clarified. And then the customer has a real choice between visus and appearance, or weight and glass thickness.
Yeah, thanks.
Okay, Fritz, do you show your customers mineral and plastic glasses for a direct comparison?
Not really. Also nicht wirklich, sondern es sollte eine Erklärung, dass man diese Brillante sehen, den Faktor, den negativen Faktor einer erhöhten Glasdicke dann in Kauf nehmen muss.
Yeah, so Fritz isn't actually displaying or letting them test the difference between the silicate and Kunststoff, but he's explaining the values and the differences to them so they can make a value decision themselves.
Mm-hmm. Okay, and let me ask you another question. What is the physiological reason behind your recommendation not to split the prism for lower prism values? From a pure technical point of view, I would always split them, or this is at least what I've heard so far. And can you explain this a little bit more in detail?
Ja, gerne, gerne. Das sehe ich von Seiten des Refraktionisten aus. Und zwar nehmen wir ein Beispiel an, der Kunde braucht 4 Basisinnen. Dann wäre es im ersten Schritt 2 Prismen pro Seite. Ich mache im Refraktionsraum aber die Erfahrung, dass ich den Kunden nach seinem Empfinden frage. Ich stecke die Gläser also in die Messbrille und lasse ihn laufen und frage, ob er sich wohlfühlt. Und während der Refraktion im Vorfeld habe ich sein dominantes Auge ermittelt. Das Dominante bedeutet empfindlichere Auge. Und jetzt verteilen wir die Prismen asymmetrisch. Sagen wir einfach mal 1:3. Oder bei einem geringen Höhenprisma nur eine Seite. Und wenn ich den Kunden wieder laufen lasse und ihn frage, wie fühlst du dich, bekomme ich eine Antwort. Und bei welcher Tragesituation er sich am wohlsten fühlt. Und damit sind vielleicht auch Reklamationen im Vorfeld schon reduziert, weil allein aus dem Grunde, dass ich den Kunden in den Entscheidungsprozess mit eingebunden habe, habe ich auch einen höheren Erfolg. Farbsäume sind nämlich nicht zwingend sichtbar. Sie werden ja trotzdem visusmindernd. Und am Ende muss natürlich auch die Brille ästhetisch schön sein und die Glasdicke und die Brillanz der sphärozylindrischen Kombination mit ihrer Achse, das ist die Aufgabe des Glasherstellers. Das kann ich gar nicht machen, wie in einem gerandeten Zustand das alles zu berechnen. Also diese Kompetenz liegt eindeutig bei der Industrie.
Okay, Fritz, I'll do my best. That's quite a long answer. So Fritz is talking from his own experience, and he's talking from the refractionist point of view, so from the optician. And he said that I let the customer experience with the determined values. So let's take the case of a base 4 inside. So that's to say you've got prism with value 2 on both sides. And then I let the customer test this with the trial glasses and to get his experience and see how comfortable he is with it. And then Fritz will offer the client or the patient in this case the opportunity to try an asymmetric balance, let's say a 3:1, and then he will ask for the customer's feedback. Now, Fritz is also aware that the customer could be affected by color fringes, but the customer won't see the fringes himself. He won't be aware of the fringes as color changes, but there will be a detrimental value to the visus, of course. But the customer won't be aware of this, but Fritz can then measure whether the customer is more comfortable with an asymmetric balance or not. it could be possible with low values, low prismatic values, that all of the value is put on one side. And then Fritz has also mentioned that he's going to measure the dominant eye. I think you do that with Pascal, don't you, Fritz? And with this knowledge, he can then interpret whether the customer has a better feeling, a more balanced feeling, using all the values on one side, be it low values, and letting the dominant eye have its right of way. I may have missed something off there, Fritz. It's just, look, I did that without looking at my notes. So as for calculating the thickness of the glass and the concerns of spheres and axes, for example, Fritz believes that he can only give information to the glass Hersteller and to the lens manufacturer, and the industry must then interpret this, and that is the responsibility of the lens manufacturing industry. Mm-hmm. About right, Fritz?
Yes, thank you.
Okay.
Peter?
Yeah, thank you very much for your answer. For me, it's very interesting to hear that you really test the distribution of Prism with your customers, and I just got the idea to repeat such a procedure at my school with the students. Because it seems to, for me, it's a very interesting approach you are taking.
I also have one further question. Can you tell me, Fritz, in your experience, how often do the people say that they like to have the prism just on one side, for example?
I understand. In most of the cases, the Entscheidung, the decision is for asymmetry.
Ah, okay.
Die Entscheidung ist für unterschiedliche Prismen.
Okay.
It depends, also es hängt von dem wirklich dominanten Auge ab. Wir haben ja nicht zwingend immer ein ausgesprochenes dominantes Auge, so wie wir manchmal ja auch nicht eine ausgesprochene Händigkeit haben. Aber wenn ich eine ganz klare Dominanz feststelle, stelle ich auch fest, dass eine asymmetrische Prismenverteilung der bessere Weg ist.
Okay, thank you.
But essentially, Fritz said that his experience is that when he runs this trial, the patients always settle for a asymmetric distribution. So particularly where there is a strong dominance with one eye, then it makes sense, and there's a lot of value to allowing that eye to be uncorrected and to put the full prism value or full prism correction on, can I call it the lazy eye or the non-dominant eye?
Yes, yeah, thank you.
Does that answer the question, Hannah?
Yes, it answers the question. Thanks.
Fritz, last but not least, I would like to ask you if you can give us an example of a patient and the accuracy you need to correct this patient. Can you report another study case?
Ja, gerne. Gerne. Ich habe einen Kunden morgen noch gehabt, der hat unterschiedliche prismatische Wirkungen im Ferne und in der Nähe.
Okay, I had a patient this morning and he had a different prismatic value in the distance and for the near reading value or the near value.
Und er reagiert sehr empfindlich auf eine halbe Prismendioptrie, mehr oder weniger.
And the patient was very sensitive to a change of half a prismatic value.
Nehmen wir an, er braucht 4 Basisinnen.
Let's assume that he wanted a base 4 and a base 4 inside.
Und er kann sich aber nicht so genau zwischen 4 und 3,5 entscheiden.
But he can't really decide between 3.5 and 4.
Und zu unserem Thema, wenn ich 4 jetzt nun bestelle und mit allen Parametern kommt leider die Richtung 4,2, 4,3 raus, dann ist das ja die falsche Richtung, die der Kunde eigentlich bräuchte.
Yeah, so when I order a value 4, and when I mount that in the glasses and the resulting eyewear has a value which is slightly higher than 4, then the failure, the errors have been added in the wrong direction.
Ja, sehr gut. Und ich möchte die Sicherheit mit meinem Partner in der Industrie haben, dass, wenn ich 4 bestelle, auch 4 in der getragenen Brille sind und ich so mit dem Kunden eigentlich in einem Troubleshooting oder auf der anderen, woanders nach einem Fehler suchen muss, nicht beim Glashersteller.
Yeah, so Fritz says that he wants to have confidence in the industry that when he orders a 4, he receives a 4 when it's mounted in the finished eyewear, so that if there are any problems after that, he can search in other directions, knowing that he has confidence in the industry that they've delivered what he's ordered.
Thank you very much, Fritz. Confidence in the industry, that's a very good closing statement. Thank you, and I return the microphone back to Hannah. Thank you.
Yeah, what's left to say? I also like to say thank you, Fritz, for your very interesting lecture and for answering our questions. Yeah, thank you, Peter, for your challenging questions, and of course, thank you, Eric, for your great translation.